This is another problem that uses the distance equals rate times time formula. It's a somewhat creative use of this formula in that it isn't it seems like a very complicated problem that is made very easy by a little bit of a creative means of understanding the problem. Now, one thing about this particular problem is it's obviously unrealistic. If two people are 25 miles apart, they are not going to be throwing a ball to each other. But let's just assume that this is possible. We did it in miles just because it makes it easier to do the numbers. So assume that this situation is realistic as we do it. So what's happening is you've got Jim and John, and so you got Jim here and John here, and they are running towards each other. But at the same time, they're throwing this ball, and this ball is going back and forth. And so, if Jim throws it first, then when he throws it, John's going to catch it somewhere, but he's not going to catch it. So from here to here is 25 miles, right? He's not going to catch it after the ball's been traveling for 25 miles because John's traveling while the ball is traveling. And so somewhere here, John's going to catch it, and then John's going to throw it back, and then somewhere here, Jim's going to catch it, and so there's this process that's going on where the distance they're throwing the ball is less and less, and it seems very complicated, and it actually is very complicated to try to solve the problem like that. But it's actually a very easy problem to get to an answer because the distance the ball travels is just distance equals rate times time. We know the rate the ball travels. The rate the ball travels is 50 miles an hour. So if we want to find the distance, then all we need to find is the time. Well, we can find the time because the time that the ball is in the air is the same amount of time that John and Jim are running towards each other. And they are running towards each other at 5 miles per hour, and so the distance of John plus the distance, and I'll use M for Jim, has to equal the 25 miles because they're running towards each other, and so they're both running part of the 25. They're running at the same rate, 5 miles an hour, and their time's going to be the same, so we'll just call that T. And so that means John and Jim's time is just 2.5 hours. And so they both run for 2.5 hours. The ball is being thrown for 2.5 hours, so all we need to do is substitute in for T, 2.5, and we get that the distance the ball travels is 125 miles. Seemed like a very complicated problem that was made much easier by thinking about distance equals rate times time for both situations, the people running and the ball running, and then the key trick or the key creative way to solve was to recognize that the time of the people is the same as the time of the ball.